LLM Mind Simulation is a real-time cognitive processes simulator for using an LLM, which generates active thoughts based on an initial condition or initial situation, and in a free-form way actually explores the initial situation that is given to it by generating thoughts, and we store these thoughts into its memory. This memory is a vector database that is in cache. We also store it as a JSON, but we keep it in memory and it retrieves from this in each iteration. It also generates current beliefs and it generates questions in each iteration to prompt itself based on the thoughts that are retrieved to further its exploration. And every so often, it actually forms conclusions and its current emotional state and arousal level changes, as well as the question that is currently is in focus. For example, this was so started with the initial situation of what is the sum of all natural numbers. So it's not currently running. So let's begin by running to try to better understand it. So let's run this from scratch again with the initial situation of what is the sum of all natural numbers. I'm going to run the app.py file. You can run this both as a separate terminal version or as the web app. As the web app starts, I'm going to refresh this. As you can see, all the placeholders are empty currently, and you will be able to see the process taking place in the terminal. We will examine this. A new folder is generated with a lot of JSON files, and embeddings are being created and stored and retrieved actively. So the first focus is what is the sum of all natural numbers, and then it generates thoughts, and based on those thoughts, it generates current beliefs, and it actually stores those thoughts in its memory, and then every step of the way, it retrieves from those memories. As you can see, we are performing similarity search, and it updates its current state, picks a new question, and continues and continually form conclusions. So this is an open-ended exploration mind simulation, which is fully self-contained. Let's take a look at the terminal to see actually what is happening. As we can see, when the mind starts, let me actually zoom in here a little bit and maybe move this to side. So we're still running it, so these will continually update. So when the app first starts, we start the mind simulation. There's 0 memories and 0 embeddings. At iteration 0, we process the situation, which is the initial condition. What is the sum of all natural numbers? It sets its current states, generates responses by emotional component. So there's two components to the mind, but one an emotional component and a rational component, and they both generate some thoughts. Then we store those thoughts in memory, and then we search its memory for relevant thoughts, and if we update its conscious state, and then we print the updated state. Currently, it actually moved from neutral to curious, and its attention is currently on the original questions, and it has currently 2 active thoughts. Then it evaluates beliefs and generates conclusions in the first iteration. We can set at how many iterations we would like conclusions to be generated. And in the second iteration, as it enters the next iteration, it generates a new question, it processes the situation, and it generates, using the emotional and the rational component of its mind, generates new thoughts. And then we store these new thoughts into memory, and then we retrieve the thoughts. There's only currently 2 thoughts, so they are retrieved, and we update the conscious state. It remains curious, and its attention moves on to the newer question, and it has now actively 4 thoughts. So if we were to go towards the end, we can see that as the memories update, we are able to retrieve the top 3 most relevant memories, and its updated states currently includes 5 active thoughts. Maybe we are retrieving 5, but only printing 3. I'm not sure. We'll have to review the code. But this continually goes on, and as it updates, we can view its states. The source code for the LLM mind simulation is available at my Patreon. When you do become a patron, you not only will have access to the source code for this, but also to 300 other projects. We will be reviewing the code later in the video, just in case if you wanted to learn more about it without downloading it. Right here, these are its active thoughts and current beliefs and memory, along with the questions that it has generated. and its conclusion. So the latest conclusion it has reached is the interpretation of divergent series through Cesaro and Abel summation techniques offer transformative insights. So it will continue to explore this, and sometimes it may actually deviate from the original question as it keeps running. So I also have a mermaid diagram to explain this better. Let's take a look at that. So let me zoom in. So we begin with an initial situation, which is the initial condition, and then we pass that to the process situation method. And then this generates thoughts, this generate thought function uses both the emotional processor and the rational analyzer. And we log those thoughts into JSON, also JSON files. And these process thoughts from emotional and rational center goes to we store memories, and it goes to memory system, and we store those as embeddings and as JSON into files. Then those memories are retrieved for the current situation, and we update the conscious state, and then we evaluate the beliefs, as well as update the conscious state and save the logs. And then every so often we go to the conclusion generator, we save those as well. And once this is done, then every so often we generate the conclusions, and then from that we generate new questions. The new situation becomes the new question. Then the loop iterates. So I am providing both the markdown files to explain the code in detail, plus the one for the app. So there's two files. One is mine with embeddings, memory retrieval with beliefs final. So this is the terminal version. And then there's also the mine dashboard. Under it, there's the app.py file, which runs this as a FastAPI web app. So there's explanations for both, along with the flowchart if you want to analyze it better. Like I said, this will be available at my Patreon, but you can we will be reviewing the code, but if you become a patron, you will have access to this along with 300 other projects. And if you are enjoying my content, you can find more of my content at my website, ecohive.live. And if you're a patron, you can find the convenient code download links for each one of the projects as well. I currently have over 350, maybe over 400 projects actually. Just have to update the number on the website. So if you do decide to become a patron, I appreciate your support because this is what I do all day, trying to create interesting and useful projects. So before going on to the code review portion, let's take a look at its latest state in the Mine dashboard. So its latest conclusion is that the application of Cesaro-enabled simulation techniques has the potential to transform the understanding. So it's really interested in Cesaro-enabled summation currently. And it is still ongoing. You can explore all of its thoughts. As you can see, it has accumulated quite a lot, explore the generated questions, and explore the current beliefs. It says that its latest current belief is that application of Cesaro-enabled summation techniques can significantly enhance our understanding of the summation. Let's also take a look at the mine logs. Here we have the thoughts that are generated along with their source, intensity, right here, and associations. And then we have the questions that are generated, the beliefs that were formed, along with its confidence, supporting thoughts, and the counter thoughts, and last updated, and it's their stabilities. And here are the conclusions that were formed. Here is our embedding database. We keep this in memory, but it's also saved as a JSON file. Here are the memories and the states. Currently, its dominant state is curious. Let's see if it has changed lately. It's still remaining at curious, but this can actually change between multiple emotional states that are defined right here: happy, sad, angry, curious, anxious, and neutral, but mostly remains curious because that is what it's designed to do. And as a final note, like I said, this app comes in two parts: the mine with embeddings, memory retrieval. That .py file runs in terminal completely independently, and the app.py file actually imports it, okay, and actually runs it as a FastAPI app. You have, if you do run the FastAPI app, you have to set the initial situation separately to pass. Otherwise, you can set all of the configurations here at the very top of the terminal version of the file. This conclusion interval is how many how many iterations you want to generate conclusions. There's a sleep duration between iterations. To better be able to read the terminal output, you can increase this if you like, and the initial situation is entered right here, and you can view the rest of the log variables here as well. The code will be reviewed by the AI code explainer script that I have written. I feel like it does a better job than I do. Do let me know what you think in the comments. And the source code for the AI code explainer is also available at my Patreon as well. Link for that will be in the description and in the comment.
The initial configuration sets the stage for the mind simulation by defining parameters such as the initial situation, what is the sum of all natural numbers, logging directories, and iteration controls. This segment sets up the initial environment and ensures that all outputs, like thoughts and conclusions, are captured in their respective files. The core data models, emotional state, thought, question, conscious state, belief, and conclusion, define the structures that will be used to simulate mental states and processes. These models represent different aspects of thought and cognition, such as the content of a thought, its emotional impact, or the confidence held in a belief. Think of it like setting up the pieces for an intense game of chess. Each piece has its role and potential moves. The MindLogger class is responsible for ensuring the persistence of the mind simulation's outputs. It creates a directory for logs and provides a method to log data to specified files. So whenever our simulated mind thinks something, you can bet it's being documented. Moving on to the mind component class, this part acts as a base class for various mind functions like generating thoughts. Each component will generate thoughts based on context via the powerful and insightful OpenAI API. It's like having individual departments of a company making important decisions based on the resources and information they have. While the class doesn't do much on its own, it provides a blueprint for more specialized components. Here, our mind simulation gets actual brainy components with some specialized functions. The emotional processor is the drama queen of the mind, generating emotional responses and thoughts based on the current state. It pretends to be an emotionally sentient part, understanding how situations might affect one's feelings. Next up is the rational analyzer, which wears the hat of a no-nonsense logical thinker. It analyzes situations to yield logical and insightful perspectives. Together with the emotional processor, it embodies the classic struggle between heart and mind. Lastly, the question generator can be thought of as the curious child constantly asking why. It generates questions based on current thoughts and context, helping explore and expand the knowledge base. These components ensure the simulation doesn't just sit around hilariously misunderstood. It actively evolves and questions its understanding of the world. This makes sure our simulated mind is not just a goldfish. The memory system handles how the mind remembers and retrieves information. Think of it as a high-tech filing cabinet. It not only stores new thoughts as memories, but also retrieves relevant ones using fancy embeddings, ensuring the mind isn't living in the moment without context. The way it works is by maintaining a list of memories and using semantic embeddings to find similarities between the current context and past thoughts. It's not a perfect memory, no elephants here, but it's good enough for the mind to have a reference point when thinking through complex ideas. This functionality is essential for the mind to build upon past experiences, making every thought a teaching moment. The belief system component is tasked with deciphering the mess of thoughts into organized beliefs. It's like crafting a logical understanding from sometimes chaotic thoughts. By evaluating whether a new set of thoughts makes sense as a belief, it performs a job similar to a detective piecing clues together to solve a puzzle. This system evaluates thoughts, decides whether they align with existing beliefs, and updates or creates new beliefs accordingly. It ensures that experiences shape one's belief over time, much like how your belief that chocolate is the best dessert could evolve into a stronger or shakier stance based on dessert explorations you experience. This process contributes to the simulation by providing a mechanism where persistent thoughts can synthesize into coherent mental models paving the way for advanced interactions and decisions made by the simulated mind. The capstone of our simulation's reasoning heavy lifting, the conclusion generator synthesizes all the muddled thoughts, beliefs, and emotions into succinct conclusions. It's the epiphany moment of the mind journey, where it all comes together in a nice aha statement. This class takes stock of current mental processes, beliefs, active thoughts, emotional state, and manages to output a conclusive understanding of the mental situation, underscoring the mind's progressing comprehension. By turning chaos into clarity, it enhances the overall simulation by providing milestones of understanding to document and reflect upon. It's like finally solving the Rubik's Cube of one's contemplations. The mind class orchestrates the various cognitive components to simulate an entire cognitive process. This includes generating questions, processing situations, updating conscious states, evaluating beliefs, and generating conclusions. The mind acts as a project manager, ensuring all components work in unison to achieve a cohesive mental simulation. In process situation, the code simulates the reaction of having the mind process a situational prompt. The simulation examines how different parts of the mind respond, how thoughts are stored and then integrated into the conscious state, leading to possible updating of beliefs. Finally, the explore method manages the primary loop of thought exploration, continuously cycling through situations and iterating thoughts, questions, and conclusions. It's like going on a mental adventure, with each iteration opening new opportunities for self-exploration and understanding, indefinitely, or until the defined number of iterations is reached. Overall, this class structures the interaction between different mental processes, allowing the simulation to run smoothly, indulge in introspection, and reach insightful conclusions about its existential journey. The main function demonstrates how to initialize and start the mind simulation. It's like saying, "Gentlemen, start your engines for our simulated mind journey." It initializes an OpenAI client, creates an instance of the mind class, and begins the mind's exploration adventure with an initial situation. Using the SEO library, Main manages asynchronous operations to ensure that different simulation processes, like generating thoughts, storing memories, etc., are handled smoothly. This kickoff function is the entry point for our intellectual escapades, making sure logs are prepared and the simulation begins its thought processes. By providing the structural foundation and starting point, it helps make sure the advanced concepts of a self-exploring mind run effectively, set to reflect and adapt to its evolving thoughts and beliefs.
I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the FastAPI course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.
Welcome to the imports and initialization of our FastAPI app for simulating a mind. This initial part sets up the scaffolding for our application. We bring in some usual suspects, like FastAPI for creating a web app and WebSocket for real-time communications, among others. We also reach out to some packages for file operations and monitoring, in case the mind decides to pull any late-night file shenanigans without telling us. We use FastAPI to create the app, static files to serve static content, and some nifty directory checks to ensure that the app's essential paths exist. Contributions. FastAPI setup initializes the app for handling web-related tasks. File system. Ensures it has the necessary directory corralled so our dear mind won't go losing its thought logs. WebSocket will come in handy for real-time interactions in further snippets. In this snippet, the code sets the stage for handling multiple client connections using WebSockets and ensuring our mind's thoughts don't get swallowed by a void due to file mishaps. We maintain a list of active WebSocket connections to broadcast real-time updates to connected clients, like a parent sharing its child's achievements with everyone. On startup, it also loads previous logs so those accomplishments aren't forgotten. The log file handler class is a guardian of our mind logs, vigilantly watching for changes to the files and ensuring that, When fresh insights or mistakes are recorded, everyone gets updated ASAP. Contributions. Active connections. Keeps track of WebSocket connections for real-time client communication. Data loading. Loads existing log data to ensure continuity and awareness of past simulations. Broadcast updates. Ensures that any updates from the mind are swiftly broadcasted over WebSockets. The gleeful chatter of our mind with the digital world begins here, at the WebSocket endpoint. This is where we allow virtual handshakes between clients and our simulation, welcoming WebSocket connections with open arms. We first receive the connections, load existing data, because starting with a fresh mind is hard, and then ship all previous findings to the eager socket. This ensures no one's left in the dark about the mind's past revelations. Once a connection is established, it stays open, ready to receive requests or live updates as new insights are jotted down in real time. Contributions. WebSocket handling enables clients to connect and stay updated with the simulation. Data dispatching sends the client historical data upon connection, ensuring nobody ends up lost in the mind's intricate workings. And so we have a user-friendly dashboard set up, kind of like a cozy room for observing our mind in action. The GET method provides an HTML response, allowing users to visually and interactively engage with the mind simulation, just like watching a brain unravel on a screen. Furthermore, the code segment then handles the somewhat clandestine operations of file monitoring. It educates the app on keeping an eye on MindLog updates in the background using an observer, making sure no pertinent updates go unnoticed. Contributions, Dashboard Endpoint, offers a UI for users to interact with the simulation, effectively making observations intuitive. File Monitoring Setup initiates vigilant monitoring of log file activities, ensuring the simulation's activities are thoroughly followed and reported. Cue the dramatic music. This portion heralds the start of our mind simulation in the grand theater of FastAPI, making sure that the show goes on as soon as the curtain rises. This piece defines an async function that initiates and runs the mind simulation, waiting just enough for the server to warm up before throwing our little brain into the chaos of the sum of all natural numbers. The addition of the startup event ensures this simulation eagerly kicks off once the server is fully operational, proving time waits for no neural simulation. Contributions, Simulation Startup, ensures the mind simulation kicks off seamlessly with server startup, making it a smooth and eager experience for all users waiting to tune into the thought processes. And here we arrive at the grand finale, uniting all these whimsical workings to bring the mind simulation to life. The main function starts everything, verifying our directories, initializing the event loop, and kicking off our watchful file observer before strapping into the Uvicorn server, ready to hit the road at a blistering 8,000 RPM, aka port number. We handle some light server configurations to ensure it hums along nicely. In the unpredictable world of distributed mind simulations, we even include a crucial bit where we clean up like the good netizens we are, gracefully canceling tasks and stopping observers when done. In this way, the code segment pulls everything together, ensuring our mind simulation runs smoothly, efficiently, and most importantly, completely fired up once called into action. Contributions. Server setup configures and spins up the FastAPI server, ensuring it handles mind simulation flawlessly on the web. Resource management cleans up background tasks and observers when the simulation concludes, keeping our digital ecosystem tidy. This segment of the HTML file is setting up the head of a web page designed for the LLM Mind Simulation app. It includes all the elements needed to style the page beautifully using CSS libraries like Daisy UI and Tailwind CSS, as well as some custom style tags for finer adjustments. It features a dark theme with modern UI elements that support a mind visualization concept, something that effectively contributes to the dashboard's sleek and intuitive design. The styling partly mimics the sophistication of a mind simulation, with elements like gradient backgrounds, card hover effects, and animated entries, adding dynamism to the user's visual experience. Here, we see the body of the HTML page being laid out, highlighting its primary role in structuring the content presented to users of the LM Mind Simulation dashboard. The ambience set by the glowing circles does double duty, both aesthetically pleasing and evocatively cerebral, hinting at neural connections and mind maps. The layout features a header that introduces the app purposefully, and a main content grid where the mind's various states and sections, such as current state, are displayed. Each section acts as a metaphorical window into the mind, presenting real-time data in a user-friendly manner. This setup is integral as it links the grand technological AI processes in the back end to comprehensible, visual information, enriching the mind simulation experience. This script section is where the magic happens, as it dynamically crafts the different sections of the LLM mind simulation dashboard and updates them in real time, a task almost as thrilling as watching a mind think. We use a list of section configurations to orchestrate which segments get displayed, such as active thoughts and current beliefs, each highlighted in vibrant colors to differentiate between cognitive processes. The script uses a WebSocket to maintain an open channel with the server, humorously referred to as a neural link, ensuring that data arrives as fresh as morning coffee. When data updates arrive, this script methodically determines the type of data, state, beliefs, etc., and injects this information into the corresponding card section by leveraging HTML templates. Thus, it creates an interactive interface where users can follow the mental journey of your simulated mind effortlessly, keeping neural activities transparent yet neatly organized. This closing segment of the HTML file includes functions and event handlers that animate the dashboard and ensure it remains a well-oiled machine. The key function update state refreshes the current state with the mind's latest readings, utilizing dazzlingly dynamic features like progress bars to display emotional arousal levels. Meanwhile, add entry injects new thoughts, beliefs, or conclusions into their dedicated sections, complete with a cool timestamp and intensity bar for visual flair. Like removing cobwebs from your brain, Clear Container ensures these sections stay tidy by reinitializing them on new WebSocket communications. The WebSocket listeners, which handle messages and errors, play an essential role, making sure the communication stream flowing from the server's mind to the user's view stays pristine. Failed connections are humorously acknowledged, albeit with a hint of irony regarding neural link disruption, keeping users in the loop on the system's status. Together, these elements form the interactive portion of your LLM mind simulation dashboard, allowing real-time, eye-catching representation of abstract mental data and helping users feel like they're peeking into the AI's thinking process.
I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the FastAPI course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.
Now, listen to me. I've been trying to code, and I like coding. The fact that I can code and make things happen, but how do I do it? Fast with AI. I'd heard about it. It's easy. So I came across 1000x cursor course. And that's great, it just made everything super silky smooth. It just worked. I'm telling you.
1000x your coding.